Hello friends, I'm Mohnish and you're watching Codex-Mohnish. So today we are going to have a look on two codes, two source codes, like which is typed by me, and now we just go through the codes and now we see the Visual Studio Code. So now I'll just make the size little big so it will be easier for you to see. So here in this code we are just trying to, I'll just give an overview. So in this code we are just trying to move the vehicle and we're trying to get the camera view of it. So we are having something called camera sensors in the Carla. So we are trying to put that Carla sensor onto the car, and from that camera sensor, we are trying to get the live feed, what's happening in front of the car in the Carla, like in a CV2 screen. So that's very simple. And after that, we'll be changing that to a depth sensor and seeing what are depth sensors. So we'll be also having a look at LiDAR and the semantic LiDAR sensors again in the next few videos. And the second code is like here, we'll be using the ArcPass. So we'll be learning about this ArcPass module in Python. And now just let's get started. So I'll just explain the code. So first we are trying to import the libraries. So here we are trying to just get the Carla EGG folder. So if you don't know what's that, so I'll just show you. So this is my new Windows 11 PC. So I'm not much experience with it, so it might take me time. So you see, wait, data. No, no, not this, not this. Dist. So you see, we're having this EGD folder. So this is like the Carla here. So we are trying to import a Carla using this one. So we are getting the file. And now we are just importing Carla, but you see we are using a 3.7. You see, yeah, we are using not base. We are using a virtual not virtual environment, like just an environment in 3.7. And then I'll just select this. Then we are setting the image width and image height. So we are, as I said, we are going to get a camera view of that what's happening. So to see it, we are just setting the width and height of the image. So width will be like 1366 pixels and height will be 768 pixels. And then we are setting the image. So I'll get to this function afterwards because that's the end at the end. And now we are just trying to connect to the clients, like this is the local host at 2000 port. We can even connect to, I think, 5000 port, I think. Okay, and like 5000 port is for live servers and all that. So if you use this extension of live server, so this one, so this uses ports like 5000 and 5500 ports and the same local host like 127.0.0.1. This can be also written as localhost. Okay, we are just setting the timeout as 2. If it does not respond in 2 seconds, then we are going to kill the term, like the code. Like we'll just kill the execution. We'll stop the execution. We are getting the word. We are getting the blueprint. We are setting the model, like which car, Model 3. We have more models also, like Mustang, Police, then Audi A2 something. So I'm not known with those models much, so I'll not discuss much. And so now next, we'll just we are just setting a random spawn point here. So we are getting the map. From that, we are getting the spawn points. And we are setting random dot choice. So choice is a function of random. So this is a list of the different spawn points. So from that, we are taking one spawn point in the XYZ axis. So random dot choice is helping us to do that. So random is a module which we imported. And then draw vehicle. This is the vehicle which we are dropping. Like this is the vehicle that's we are spawning onto the, we are spawning it on the Carla. And we are applying a control. Like first we are trying to go little right. Like so you see throttle is like the velocity and like it can vary from 0 to 1, and steer it can vary to -1 to 1. So here positive value speeds it needs to go to right side, and negative values for steer is towards the left side. And no, then we are adding one sleep function, a time dot sleep. So it will wait for 1 second, and we are setting our autopilot. So after that, we are just setting autopilot. So even though if we comment this line, they'll be like, this line is not of such importance, but then also I've written it. So here is the main thing. Here we are trying to set the camera. So here we are setting the location and rotation. So we want the location of the camera to be nearby the drop vehicle. So it should be on the drop vehicle, then it will be better. So as the camera moves, the drop vehicle moves, the camera will go with it. So that would be better for us. So for this, okay, so here we are having a variable simulated camera location and rotation. So here we are setting a transform, we are setting a spawn point. So the spawn point is for the car which we have used. So you see the spawn point contains the spawn location of the car. So from that we are getting its location and rotation. And from that location we are just adding some not get forward vector into 30. So here a forward vector is like something like 1, so it will go 30. So as we are looking into the execution, you can understand what this means. And yaw. So here we are having some terminologies related to camera like yaw, pitch, and roll. So yaw, pitch, roll in camera. So I'll just show you the yeah. So this one. So you see, yaw is like rotating something around the z axis, like it's just rotating like this, and roll is just like rotating it like it's like focus like FOV, and pitch is like rotating it so you see like it's hard to show with hands, so you can see in the image how the rotation happens. So you're just setting the yaw. Okay, wait, this came here. Okay, so we are just setting the yaw to 180. So like it will like instead of looking at the car, it will look opposite to the car. So what is in front of the car? So it will look not at the car, but in front of the car. So now we are just getting the spectator, like we are making it spectator. Like we can't see the uh, like we can say the sensor, but as we are setting into a spectator, and we are setting in the camera simulation sorry, location and rotation here, like, and we are dropping the vehicle and the camera. Like we did not drop the camera yet, so like this code should have been written here, so it would make sense. Uh, then also like just like that, I wrote it here. So now let's get to our camera sensor. So we are finding the cameras like sensor or camera RGB. So this is a RGB camera. So after this, we'll be looking at the depth sensors. So wait. And now we are setting the attribute of image size X. Like this is an attribute to IM width. So we define this here, and IM height like here again. So I can use control click also, like just go here again. Okay, so now if I see, we are just adjusting the FOV also, and we are just setting the location to X is 2.5 and Z is 0.7. So it will spawn 2.5x front of the car and 0.7 Z up. So now we are just spawning it with the location rotation, and we are attaching it to the drop vehicle. And then we are appending the sensor also, and we are listening to the image. So image is like we are listening to the sensor, and we are calling the function image. So this image function is written here. So from that image, we are like it sends us a positional argument. Like sensor will send us an argument like with the data, but here we have written this image, and then we are setting a matrix representational data, and we are making it a numpy array. So numpy, like we use it with to like manage list efficiently. Like it also saves storage, it makes the code faster. Like, and that's it. Like, and we are just getting the raw data from it. So we are just getting the image and raw data, and we are reshaping it into image width, image height, and 4. And then we are getting the live feed from the camera, and we are reshaping it like this. We are slicing the whole thing. That's it. And then we are just showing. Okay, I'll just keep here car view. So that window will get a name like car view. And I'm just setting the live feed, and I'm just setting the wait key to 1. So wait key is like after how many milliseconds do you want the image to change. So 1 will be like best, so because we are faster, like we want to go to run fast. So I'll just open a terminal in Visual Studio. So now you see, okay, I'll just run the Carla first. So Carla, I'll just run on low quality level. Quality level equal to low. Okay, now, okay, that's now we'll just cd Python API like where our file was. So this is old code. And from that we'll set Python project 205.py. That's the file. So as okay, before I run it, I'll just do here control B. So if you are able to hear my CPU fans, so like I'm very sorry, like I can't help it. So now I'll just run this code so we can see live what is happening here. Like, okay, so this is our car view. See, this is the car view. So this is the front of the car, what's happening. So I'll just show you, see, just set it here. Okay, so we can't actually set this thing because, so if you see here, the car, like this is the surroundings in front of the car. So as it stopped, you see, and now it will turn. So this will also start turning. So you see, you get the things here, like the buildings which are this side. So like actually, so you see the road and this camera sensor. So they are the same. So this is what the camera sensor does. So I'll just do Control C here, and then I'll just change that sensor here. Wait, where's the sensor? Okay, I'll just do Control F, sensor dot camera. Okay, okay, I did this thing dot. Okay, so you got it. Now I'll change this to depth. DPTH. So now you see, like this is one more sensor. So we may or may not be discussing about it, but I'll just show you. So we get the depth. So depth is like distance here, like distance. So it will just try to give random color codes. So like according to the color codes, you get the things like this. Okay, so this is one more spawn location. I think it spawned here. So you see, it spawned here and went here this side. So you see the surroundings are matching, but you see the weirdness, no? Like it's trying to measure the depth. Like depth is like if there's a like pit hole here, like for example, so it will detect it. Like we can see distinct, like we can see the color here, like red and all that. So that's the depth sensor. Like there's nothing much in depth sensor. So now I'll just kill this. Okay, now I'll just minimize my terminal and we'll just go through our second code. So which is using the arc pass. So we are just doing the same thing we did as the and actor list. Okay, now this is the new thing here. Parser equal to arc pass dot argument parser. Description equal to give the parameter. So here we are having the argument parser. So as you saw while I was starting Carla, okay, I'll just open the terminal. Okay, I just killed it, I think. Okay, no Carla, you yeah, this is there. Okay, the session got erased. So okay. So while I start typing it, so I typed Carla hyphen quality hyphen level. So these are the arguments which I'm giving while I'm trying to run the program, like Carla. So here we are also trying to give the similar kind of arguments before we are running the program, of course. So these arguments can be collected from the CMD through arc parser. So we are like this is a method arc parser is the module. From now we are calling a method function argument parser and we are setting the description to this. So that's not much. So parser, we stored all of this in parser and we are adding an argument which is hyphen car and metaver we are not setting any metaver and we are so description is car like it's a car and error number of arguments is only one. We want only one arguments. So what's the default value? For example, if the user does not give any value, so how do we handle that? So we are just giving a default value here and help. So this will be shown if you type any wrong thing like example. This is taking the thing in integer like strings. So so if I type any float values, like it will be stored in the string. So like when we are setting the meta like for example n like integer. So that time if someone types string value, so we might get an error. So it will show help that time. So we are setting the arguments args equal to parser dot parse args. So this will give us all the arguments. If we have 10 arguments, so it will give the 10 arguments with the position. Like first if I have car, then if I give this like speed, steer, then the spawn point. So these all arguments can be like collected from the args. So we get it from parser.parseargs. So here I'm just printing the like args.car. So this will have the car, like it will have what the value kept slash n, and we're printing the type of it. And here we are having a main function which is getting a parameter arg. So here we are calling the client and all that, right? So this is a thing. So here what we are just taking the car. So we are setting here the arg.car 0. So as this is a list, so when you see the type of the car, you will get a list. So we have to give the 0, and 0 is like, so here if we have model 3. So model 3 is not one car. So we have many cars like model 3, model 3, model 3. So from that if we select the 0, like model 3 0, so it means there's a list of model 3. In this we are taking the first car. So that's what we are doing. So don't get confused. So this is in a parenthesis. You see that, and then we are setting a spawn point of same code. Nothing change. So I think here we are not even okay. We are adding autopilot, and we are adding a sleep, and we are destroying the vehicle. So here we are calling the main function, which we just typed here. You see main def main, and okay, I just made it small. Okay, sorry. And now we are setting the args. So args is what we got here. We are setting it here, but here arg. So we can give any name here. So if I just give arg chill, okay, I'll just control F, control H. So I'll just do args args. Okay, just change it to args underscore chill. Okay, that was not what I wanted to change. Okay, I'll just change this. It only passes dot args. Okay. So I'll just see if I did not change anywhere else. Like args chill, args chill, args chill, and here args chill. So this is the parameter which we are setting, but in a function, so args chill will be assigned as arg. So we'll be just seeing that. So okay, where's the terminal? Yeah, I'll just close it, right? Okay, I'll just make it like this. Let's go here. Okay, so wait. Okay, Carla. Okay, yes. So Python. So first we are going to check with the default settings. So which will be model 3, which we are using. So I'll just run it. So we should get a model wait. Index out of range. Okay, okay. So I need to keep it as a list, I think. Wait, so this was not expected. Model 3 default. Let's keep it in a list, maybe. So this might help. Okay, so I'll just run the code. Okay, I'll just make it till here, and I'll just clear screen. I'll just run the code again. So I think we should not get in. Okay, see, you see, model 3 class list. Okay, so because I'm making a 0, so I'm taking args card dot 0. So I need to, like it's a list. So the default value should also be a list. So you see, we got a car here. This is model 3. But now we'll use trying to spawn, like I'll just state car, like that's what we kept here. See, you see, parser dot argument hyphen hyphen car. So now we will give a space, and now we'll give Mustang, Mustang anything, and now we'll just enter it. So now you see, so Mustang is the args_chill.car. So if we have any other parameter like spawn, so we can also give the spawn like that. And now we are just printing the type of it like list. So r_still.type. So we are just printing the type. Okay, wait. So I think it like I just like my head was here, I think. Okay, so it's a traffic signal, I think, maybe. So that's why it's stopped. Okay, so we don't like that's not. So we'll just try to spawn one more car. Police. Police. Okay, so I think we should not get the same. I think I kept the same location. I think not random. Maybe. Okay, so no, it's random. So you see, this is a police car. So first is going towards little right. Like that's what we added here, I think, or maybe something I don't know. Like so, you see, the autopilot is setting the things now. You also have other cars. Like I just you can just go through all the cars. Control C. So you have a car list in Carla, so you can of course go through that. So thank you friends for watching my video. Hope you are good and see you again. Bye.